Hello, this is Team 18 and this is our presentation for the design defect and documentation of boarding early management system. The team members are Harshit Patni, Nakul Vaidya and Furqan Ahmed. Let me start with the contents of this presentation. Firstly, I will show you the product overview. Then we will do the analysis of original design. We will also talk about its weaknesses and some of the strengths. We will also identify the use of design pattern in the original design. Then we'll look at the class structure and the uses of classes in the original design. Then we have also identified several metrics to determine the code quality. Then on identifying the problems in the matrix, we have refactored designs, identified some code smells and refactored the class structure to make the design better. We will talk about that. We will also talk about some of the design patterns that we have introduced in the code, and finally we will show you the matrix analysis of the refactored code. Starting with the product overview, boarding management system is basically the implementation of existing software system designed by the Lucky Strikes Boarding Center. The sum of the features is that there are several lanes, and each lane can there are several parties, and each party can register to one of the lanes, and in each party there will be at most 5 players. So as soon as the players forms a party and registers with the lane, the game starts. The game is being simulated automatically, and we'll get to see the scores through the pin setter interface, which shows the number of pins that have been balled down by the player, and the scoring view, which shows the scoring for the current strikes and spares. The original design can be seen from with 3 different points of views. First is the set of different quality attributes view, then architectural view, and design and implementation view. So the current code tries to implement command pattern but fails to do so due to lack of OOPS principle implemented, and there is little polymorphism used in the code. Some of the if else statement could have been changed to match the polymorphism, and that would have given it more OOPness. This is the UML diagram of the class before refactoring. As you can see that on the top left side you can see some of the classes which don't really fit the OOPS hierarchy, and they are standalone classes. So these classes don't really have any meaning in terms of the OOPS principle in this diagram. And then some of the classes here are as you can see, this is the big class, lane class, and it has too much responsibilities in terms of number of attributes and number of functions. So these classes are in turn the controller of the whole code. Some of the weaknesses and strengths that we identify. I'll talk first about some of the problems with the existing code base. As I already mentioned that the code base violates OOPS principles several times. Moreover, existing class structures makes it up down. Overall logic in some of the classes is quite clear, but in some of the classes like lanes, it is hard to maintain and read because so much is going on in the classes. Then there are lots of nested if else statements, and as I mentioned, they could have been handled by the polymorphism. Then there are, as I mentioned again, there are some standalone classes here that don't really fit the OOPS hierarchy, so they somehow, they violates the OOPS principles. Finally, the class lane is the workhorse of this code. It has low cohesion because it is doing too much, and it has high coupling with some of the other classes because it is effectively the driver class of the code. Some of the strengths of this code is the code is highly modular, with each class occupying single file, and design carefully avoids the multiple inheritance, and most of the classes only inherit from only one class. The code also has very good documentation in terms of commit and the comments. The code heavily uses observer pattern, as you identified. The observer pattern is being used to get the updates related to the pin setters. So some of the classes registers with the pin setter observer to get the details of whenever the pins are boiled down. And I will say that it's the right use of observer pattern here in the code. Now the responsibility of each of the magic classes we'll talk about. There are I will only talk about the main classes. The main classes are the baller that holds all the baller info. Then there is control desk, which represent the control desk for each lane. And then there is the lane. Lane is represents the bowling lane, and so it handles all the logic related to bowling lane, but also act as a driver for the for calling the other functions to run the game. Then there are some GUI classes which have been named with suffix view. Then there is pin setter. Pin setter is a class which represents the pins, bowling pins, and it is shown in this triangles from 0 to 9. And when the pins are now down, the state of this pins are set to false. Then there are several other classes related to pin setter which are used to implement the observer design pattern. There is pin setter observer, pin setter event, pin setter view is the GUI class. Then there are some classes related to maintaining the scores and writing the scores in a file and generating the GUI score for the user. Now we looked into the code and identified several code smells. Although the code is very nicely written and cleanly presented, but there are several code smells. Some of these are that some of them are long method, which we found in lane class. Then there are several large classes. There are some functions, 1-2 functions, which have a number of parameters going up to 9. Then there have been several object orientation abusers. As I mentioned, that there are several classes which implement a complex nested if-else logic which could have been handled by the polymorphism well. Then there is a lot of comments. Some of them are a bit unnecessary because the code is very self-explanatory, so they are not needed. Then there is some duplication of code in terms of doing the same thing again and again with different objects and different methods, but the overall structure of the code is same, so it could have been moved to a different to a function. Then there is some high intimacy between the classes which are the workhorse like len, which has high coupling with several other classes. Then there is class le.java and drive.java and control.java. Then so le.java was basically a middleman between the drive.java and control.java, so it wasn't really serving any function. Then there are several places where the function length is very big, so they could have been reduced into several smaller functions. There are several methods which have been deprecated but not removed, and we have removed them. So these are the UML diagram look after refactoring. As you can see, this here we have simplified the dependencies after our refactoring. So before some of the classes were using the other classes, but we have removed them, and we also merged two classes, and we have also identified this control desk observer pattern. We have introduced the observer pattern in the control desk because every time some score changes, updates must be sent to all the classes which are subscribing to it. So this is the observer pattern we have introduced. Earlier was a pin setter. Then the final metric analysis, as you can see here, the McAbey's cyclomatic complexity has clearly been reduced, as you can see in the bold. Earlier, number of parameters were also a lot in some cases. We also tried to remove them. Then you can see that lack of cohesion in methods has been dealt with. Then depth of inheritance tree has gone up, but it has also it is because of introduction of some observed patterns. Then methods in terms of line of code has been reduced, and number of interfaces has also been reduced by run. So overall, this was our refactoring. I would say that the code was nicely written, although there were some code smells and some unnecessary use of design patterns and several violations of OOPs. So we have, all those things have been dealt with after the refactoring, and we have also introduced one design pattern. So that's all. Thank you.